in philosophy, we can sit around and let the best arguments win, right? So you throw out your arguments against one another and you figure out which one rises to the top in terms of overall defensibility, logic, coherence, plausibility, et cetera, empirical support. And so it's like in philosophy, we let the best arguments win. What happens in these kinds of commissions, though, is that there's another player at the table, and that's like political feasibility or kind of political likability or some other factor. And I realized that's actually a very big player. So it's not always the best argument wins.
One of the biggest risks in modern science aren't rogue technologies, but the quiet assumptions we never question. Behind the headlines about stem cells, artificial intelligence, and biomedical breakthroughs lies a more subtle story. Decisions shaped not just by evidence, but by politics, fear, and convenience. Today's guest has spent his career stepping into those rooms where science meets power and asking the questions most people would rather avoid. Dr. Insoo Hyun is one of the world's leading bioethicists, advising governments, scientific institutions, and researchers at the very edge of human knowledge. By what he discovered along the way is, in a way, unsettling. That is, the best argument doesn't always win, and ethical clarity is often sacrificed for political feasibility. In this episode of the DNA of Things, we pull back the curtain on how truth gets negotiated, how ethics can accelerate progress rather than block it, and what happens when technology forces us to redefine what it means to be human. Dr. Insoo Hyun is a globally respected bioethicist and philosopher whose work addresses the ethical frontiers of modern life sciences, including stem cell research, human-animal chimera studies, brain organoids, and the societal implication of emerging biotechnology. Operating at a rare intersection of academic rigor and public translation, he serves as an affiliate of Harvard Medical School Center for Bioethics, I should say, formerly was the director of research ethics at that institution. But today, he is the director of the Center for Life Sciences and Public Learning at the Museum of Science, Boston, and a senior researcher at the Hastings Center, a longtime leader within the International Society of Stem Cell Research. Dr. Hyun has helped author international ethical guidelines and shape how cutting-edge research is conducted worldwide. His scholarship and public engagement reflects a deep commitment to ensuring that scientific progress remains anchored in human values, dignity, and trust. Through writing and teaching and policy leadership, he exemplifies how ethical reflection is not a constraint on innovation, but it's essential biological and moral compass. Dr. Hyun, welcome to the DNA of Things.
Thank you, Jeremy. It's great to be here.
Before we dive in on the conversation, I think I shared this context last time, but I think it deserves a restatement. So I think you may know that you are the final piece of a trilogy that it seems that I've been unknowingly building here, and so that is it started with Dr. Barbara Kummerly, who I had on the show. She currently is a professor. Their location at Case Western University. I believe you spoke there once. So I had her on the show because she wrote a book, a fiction book, specifically on the topic of CRISPR, and essentially is using fiction to warn us about the unthinkable power of CRISPR, this gene editing technology. And at the end of every episode, I asked my guest to nominate my next guest, and she actually invited Kristin Lee, and Barbara, thought it was, critical that somebody like, Kristin, her voice be heard because, she's immersed in this world that we're describing now. And, after interviewing Kristin, she then explicitly nominated you as a next guest because, and to use her words, he doesn't shy away from the hard questions. regarding stem cell ethics and public policy. So that's a little bit of context insofar as how we got to where we are today. But insofar as how you got to where you are today, I would love to understand, your journey. You began, in philosophy, and now here you are shaping global biomedical standards. I'd love to, learn more about, your personal path, and then we can dive into from there and insofar as what you're working on today and the future that you're trying to bring into reality.
Yeah. Well, the connection I have with Case Western Reserve University is actually quite strong. I was a professor in the medical school there for 18 years before moving off to Boston when I became the director of research ethics at Harvard Medical School. So lots of really great fond memories of Cleveland and of Case Western Reserve School of Medicine. My kids grew up in Cleveland. So yeah, so this connection is very strong with Case Western. But it was interesting because I ended up getting tenure at a medical school. And the reason why that's funny to me is that when I started off in college, I was a pre-med biology major. And I ended up switching to philosophy my freshman year, at the end of my freshman year. And I remember at that time thinking, wow, I guess I'm sort of turning my back on medicine and going into the humanities and ethics and philosophy and kind of, abstract theory. And it's just interesting to me that at that time, I would have never guessed that I would end up basically building my academic career in medical school and being on the faculty there and getting tenure, becoming full professor. So that's kind of fun. But anyway, getting back to, my beginnings, the reason why I mentioned the connection to biology at the very beginnings of my academic work at Stanford as an undergrad is that I ended up using that passion later on. So what happened was I switched over to philosophy. I was very interested in maybe going on and getting a PhD in philosophy and becoming just quote unquote just a philosophy professor in a philosophy department. And at Stanford at that time, because I was getting more into ethical theory, my professors and my advisors there, all in moral philosophy, were telling me that I probably shouldn't stay at Stanford because for my PhD, because all the faculty in moral philosophy and ethics were junior faculty. They're all assistant professors. And they said, you really need to get a PhD with a senior full professor somewhere in the philosophy department. So I asked them, where should I go? And they said, well, you should really think seriously about Brown University. There's somebody there named Dan Brock you might want to work with. So I applied, I got in, I ended up working with Dan Brock. The person who gave me that wonderful advice, she was at that time an assistant professor of philosophy, but now she's the dean of the humanities at Stanford, Deborah Satz. So she was the one that gave me that wonderful advice. So I ended up going, to Brown, and I was studying philosophy, kind of thinking I was going to do ethical theory. But what was so interesting was when I got paired up with Dan Brock, and he was my dissertation advisor, I didn't know until I met him that he was a very prominent bioethics scholar. So at that time, he was on President Clinton's bioethics council. Every president up until Trump actually and Biden had a bioethics council that would give them advice at the executive level. And so Dan Brock was on, this bioethics council. I thought that was pretty cool. And what was so weird, part of the theme for today is sort of, life is very unexpected. There's never a straight path to where you end up. And in 1997 was when human embryonic stem cells were first isolated and derived, grown at the University of, 1998 was the first year that ES cells were first grown at the University of Wisconsin. And then 1997, the year before that, was when Dolly the sheep was cloned. And it was right at that period. So stem cells were emerging. This whole, amazing technology of nuclear transfer and cloning was also developing for mammals. And so President Clinton asked for an ethics report from his council on the ethics of human cloning. And my advisor, Dan Brock, was the lead of that. And he asked me to be his research assistant. And so that's how I got interested in bioethics. I thought, wow, this is an area that combines philosophy, politics, religion, biology, all together. And it kind of gave me an opportunity to go back to an interest that I had in biology, specifically developmental biology, and combine that with ethics. So that's that's where I got my first taste of kind of international, big science, big biotechnological innovation, and huge ethical implications all wrapped together. And that was also the time in which human embryonic stem cells first started as a field. And so just leaving grad school right at that time when those things were emerging and needing to have some sort of, academic identity or area of focus kind of gave me the perfect opportunity just to ride that wave. And it's just been a crazy ride ever since then.
Um, I so many questions right out of the gates. Interesting. You mentioned that every administration. I think you said, was it up to Trump or up to Biden had?
Yeah, so Carter had one. I think every it's from Carter on. They all had like about
Butter on to.
Obama had one. Biden, I believe, did not have one, or if they did, they didn't do very much. And Trump, and neither his administration's had a bioethics council. The really influential ones were, I think, the Clinton Council and the George W. Bush Council. Those were the two biggies, especially.
Mhm. And I mean, what one of my guests I had previously was Dr. Joe Handelman, and he was on the scientific advisory board for the Obama administration, and her expertise were microbial diversity, metagenomics, but really co-opted for epidemics and pandemic research, and so I mean that was fascinating to from her perspective as a scientist, getting to kind of converse with and not always necessarily influence scientific policy. And I think one of the things that came out of that is as a scientist you come in, I think, with a particular worldview, and you're not necessarily privy to the whole picture that the administration is trying to navigate. So I'd be curious to know, like, what was that experience like with you? I remember when Dolly was cloned. As about when I was starting my undergrad, and then of course the Clinton administration would have been instrumental in the human genome, sequencing the whole the human genome. So what was that like, and what what did you learn about interfacing with administration, and I guess interestingly, if why, or even if you don't, if you could speculate why like it stopped with the Biden administration, for example.
Yeah, I really don't know why it stopped with the more recent administrations, but I will tell you what I found fascinating for my involvement with the Clinton Bioethics Council was called the National Advisory Commission for Bioethics. And what was striking was, this is something I also learned from my advisor. He was said, in philosophy, we can sit around and kind of let the best arguments win. Right, sort of you kind of like throw out your arguments against one another, and you sort of figure out which one sort of rises to the top in terms of overall defensibility, logic, coherence, plausibility, et cetera, empirical support. And so it's sort of like in philosophy, we kind of let the best arguments win. What happens in these kinds of commissions, though, is that there's another player at the table, and that's sort of like political feasibility or kind of political likability or some other factor. And I realized that's actually a very big player. So it's not always the best argument wins. It's kind of which one will kind of play best in the political arena. That was kind of a rude awakening for me. And I see that happening again and again to some degree, even in like international guidelines for stem cell research. Like the political considerations, the social. It's not the ethical and legal kind of best arguments. It's sort of like, what do you think would be most acceptable to the average person, which may not be the strongest ethical argument, interestingly enough. And so I've seen that play out in many other areas whenever I do policy work, and that's something that they don't really teach you, or they don't teach. There's no course in that. There are courses in philosophical logic, there are courses in theory, but there's no course that you will learn, even as a graduate student, on kind of negotiation at the policy level. Maybe that's the best way to put it, kind of like negotiation tactics.
Right. And, this kind of, sets up this next question quite nicely. This notion that, ethics can be uncomfortable. It can be perceived as slowing things down, especially when, we're celebrating things like innovation and, and what are the constraining forces that would even say something is innovative? Like, are we talking about, like something that is measured by its economic impact? Are we talking about something that's measured by its health impact? What is it exactly? And I think those are sometimes the hard questions that we skate to the other side of quickly. Like, I mean, I experienced this in my graduate school scholarship application, for example. It was very important that you framed your research towards some specific applied science aim that was being currently recognized as a priority of the administration, the Canadian administration at the time. And so that doesn't really save space for basic research, but we know basic research is really important. That's where we get discoveries like polymerase chain reaction, which then becomes applied. But there's this kind of thinking about thinking and the thought experiment to actually get to really the deeper question, the root, if you will. And what you're describing is, I think, once you get into that, a committee type of setting, I've been, and I think this is also important context setting too for this conversation, since I know where we'd like to move is into this idea that philosophy is going to get cool again, or it's back in style. And so the importance of words and defining our terms up front. I was thinking about this notion of a problem. What is a problem, right? And I really like Peter Checklin's the way he defines it in his work, Systems Thinking, Systems Practice. He says that the problem is a situation in where there is perceived to be a mismatch between what is and what might or could or should or ought to be. And then, of course, depending on your worldview, you're assuming that we agree on that problem statement, let's say, how you view that problem is going to be based on your worldview and how it becomes prioritized, and then the tools we use to solve the problem, so to speak. It can differ radically, and it can almost seem at odds and even counterintuitive. And so the need for, I suppose, discourse, meeting people where they're at, coming to terms, seems to me is important, more important now more than ever, because you can literally, with your AI thought partner, take ideas to product in a vacuum, and they're going to be biased by what large language model, let's say, you're using by default, or you've chosen based on your own incomplete worldview, which is, we all have an incomplete view if we're thinking about our own contextual learning throughout a lifetime. And so I'm interested to learn. I mean, if you had specific instances where like ethical conversations were uncomfortable, maybe because he's done a lot of amazing stuff, like insofar as stem cells, regenerative medicine, obviously. And so where has like an ethical conversation perhaps slowed down what we thought was progress? And then, how might we kind of jump into like a mental model or a philosophical frame that is more inviting to people who maybe aren't thinking about thinking every day?
Yeah. Yeah. Well, I think a really prominent example from my past where kind of ethics and policy sort of clashed and things seemed to slow down was back in 2005, 2006. This is sort of during the heyday of this whole idea that you could take a somatic cell from a patient, use an unfertilized egg. So you basically do the Dolly procedure, right?
Mhm.
Take out the nucleus of the unfertilized egg, replace it with a somatic cell nucleus, let's say from a patient with a disease of interest, and then you can create embryonic-like stem cells from that reconstituted embryo, the cloned embryo, to make stem cells that are genetically matched to the person and to the disease in question. Now, this is a few years before iPS cells arrived on the scene, which are induced pluripotent stem cells, which was the innovation of, without using cloning technology, just taking a person's somatic cell, let's say a patient's, and reprogramming those cells directly in the lab into pluripotent stem cells, basically embryonic stem cells. So pre-iPS cell technology, the big debate was around the cloning technique, using unfertilized eggs and patient cells to get stem cells. So during that huge debate of what to do, I was working on the guidelines for the International Society for Stem Cell Research. I was the chair of the subcommittee on human biomaterials procurement. So all the stuff you would need to start stem cell lines, sperm, eggs, to make your embryos, to get stem cells from them, or IVF-derived embryos, coming up with guidelines internationally for that work. And what was very, very much the movement at that time in the US especially, was saying that you cannot pay women to donate unfertilized eggs for this research. Now, this is also the time in which South Korea had announced that they had these cloned embryos that they created, using donated unfertilized eggs, and they had stem cells that they created from those cloned embryos. This is the Wooseok Kwang team at Seoul National University. So they were making claims that they were doing that. So there was all this like desperate sort of conversation around the fact that it looked like in Asia they were leaping ahead, doing this technique, and we were being left behind in the U.S. and what to do about this kind of research. So here was the policy question. Everybody else who had come up with guidelines at that time in the U.S., this is California State, Massachusetts State guidelines, and then the National Academy of Sciences national guidelines coming out of Washington, D.C., all said that it would be unethical to pay women for undergoing the IVF egg procurement procedure, which is an invasive procedure. You have to use hormonal induction for a month, super ovulate a huge number of eggs, which you aspirate out, in a minor surgical technique, out of the ovary. Undergoing all that, they said it would be unethical for anyone to pay them for their time, effort, and inconvenience. And so the big policy question for my committee at the international levels, do we fall in line with what other people have said right before us and saying that, it would be unethical to pay women because it would be presumably too enticing of a reward. It would kind of undermine autonomy of choice to do this. It would prey upon poor women. That was all fear around that time. And my committee, my group, sub-team for the guidelines determined that no, we would go a different way. So here's where the politics and everything gets really interesting, right? Because at that time, it was still extremely controversial. We were under the George W. Bush administration. His council on bioethics, which was actually made up of quite conservative bioethicists and ethics and religious studies scholars, all said that it would be wrong, to create an embryo for research and derive stem cells from it. Even like using IVF-derived embryos for stem cell research was determined to be wrong by this committee. So, of course, cloning embryos would be even worse. It was almost like a no-brainer for people like that to say that it would be wrong because the whole activity was wrong. It would be even worse to pay women for donating eggs for this kind of research project. So that was kind of the ethos at the time, like politically, and then to get the funds released, taxpayer funds released in Massachusetts, a huge amount in California. It was kind of like the line everyone would say, of course, we wouldn't allow payment for women egg donors. And it kind of became this convenient shortcut way of saying, we're going to proceed as ethically, as we could forward. And when I was thinking through the ethics of this, I thought, well, we pay women, but not just one, we pay anybody, any healthy research volunteer that donates biomaterials through an invasive procedure. This could be a biopsy of a lung. It could be bone marrow for research, anything that involves a very painful, burdensome medical procedure to donate biomaterials for basic research, all get paid for time, effort, and inconvenience. They all get paid. It's sort of like in the IRB guidebook, even for the U.S. Department of Health and Human Services, to say that it may be appropriate to recognize their pain, their discomfort, the time it takes, the effort it takes, to recognize that effort through some kind of compensation, because that's the norm. So what I argued was, why would we separate out this population, which actually, when you look at the time, effort, and inconvenience, it's a month, 24/7 of hormonal induction, and it's egg retrieval. It's on the scale of like healthy research volunteer participation and burden, it's way, way up there. So why would we treat them any differently than any other research volunteer for healthy, research participation, for biomaterials procurement? And so we argue that different jurisdictions, different research communities around the world can make up their own mind about whether they would compensate and how much. And we wanted to say it should be on par with what you normally pay people. So it was kind of, unless you can give us a special reason why they should be treated any differently from any other group, you should kind of, justice demands that you treat like cases alike. So we departed from that, and everybody said, criticized us and said, this is going to land badly politically. it's gonna, people are gonna say that science is sort of riding on the backs of poor women. All sorts of like nightmare scenarios were being foisted. And they said people will lose trust. But we thought that was really the fair thing to argue. And we came up with that policy. And so here is this is kind of a flip thing, right? So this is where I felt that politics, yeah. I mean, if you wanted to play the political game, you can kind of go safe, but I thought that would be quite unfair to people who would be you're asking for, this level of time commitment and discomfort. And so we went the other way, and that was an example where I thought science sometimes, if you had a choice between like the politically expedient position and the ethically best justified one, that's one where I really wanted to go with the ethically justified one. So let me cut you like kind of what happened with all this. So I ended up publishing a commentary in Nature. It was my first publication, solo, where I argued, that for this approach. It was like the fastest turnaround at the time ever. I wrote out a draft. I sent it to the editor. I said, "Would you be interested in something like this?" And it appeared like a few weeks later, unchanged. And what happened was they circulated that essay among stem cell oversight committees in New York State and I believe in Oregon State. And those two states determined that they agreed with the commentary. They said we should pay them the way we normally pay research volunteers at our research institutions. And so they actually bucked the trend in New York State and in Oregon. Those are the two areas where we had the most activity on human genome editing research in embryos, because for that research, it's not for cloning for stem cells. You need unfertilized eggs. You need to kind of do your editing on the eggs or on the sperm, and you want to kind of figure out what would be the best approach for editing the germline. So those groups in those states, at Columbia, at the Oregon Health Sciences University, they're I think in the U.S. leaders on different technologies that require the use of unfertilized eggs. So mitochondrial transfer research for mitochondrial diseases, all the early gene editing stuff and embryos were enabled by the change of policy. And then, now it's very commonly accepted internationally that based on the international guidelines for the society, that research egg donation is acceptable and compensation is acceptable as long as it's in a reasonable amount of money. Yeah, so I mean, I think that's probably the clearest case where there was some question of which of the two alternative positions will slow down research the most and which will sort of facilitate it. It ended up being that the compensation route facilitated the research in other domains as well, not just in stem cells.
I mean, and you've probably heard anything that I'm about to say, you probably heard. Where my mind goes is, okay, well, what are the other stakeholders in the room? The others who are perhaps concerned. Well, what are the social implications? Like if you take into consideration social economic status.
Yeah, absolutely. I mean, so I don't mean to gloss over that, but just kind of in my quick summary, what happened. A couple of things I want to point out. One was, when the guidelines came out or my Nature commentary came out, I was invited by the National Academy of Sciences to meet with the people who came up with the National Academy's guidelines in Washington, D.C. So I'm in this auditorium. The audience for me are all the people who work on these, U.S. guidelines that said that it would be unethical to pay egg donors for research. And I thought they'll never invite me back. I'll just give them tough love. I'll say, look, which of the two is this? We have a whole research oversight procedure where we oversee through the IRB system things like who you're going to recruit for your study, how much you're going to pay them. Like the price is actually set by the IRB; it's not set by the free market. The price of compensation. Right? So we have all these controls. It seems to work just fine across all of biomedicine. So either you think that system is not adequate to provide safeguards for this, or you think there's something deficient about women and their thinking that would, despite all the safeguards, would still put them in danger of making bad choices for themselves and not acting with autonomy, but by being lured by money. So which of the two is it? Either you don't trust the system of oversight we have in place for all biomedical research, or you don't trust women. And at the break, they came up to me and they said, you know what, we agree with you. We agree that we should pay, but we didn't think it would fly politically. Okay, so that was an example. Like you're at that crossroads. You're going to go politically expedient or the best legal argument. Now, regarding kind of all the concerns people have, yes, there were lots of concerns about what would happen if you pay women for time, effort, and inconvenience for eggs. What I do know is that in Massachusetts, my colleagues at Harvard, following the Massachusetts policy of not paying women for eggs for research, they had zero volunteers. Like as soon as people came in and they got to the part of the informed consent conversation where it said, will I be paid yes or no? And you say no, they said, well, but if I donate the exact same procedure, if I donate to an IVF clinic, I would get paid. It's the exact same thing. The eggs are going to a research team, they're not going to a fertility clinic. Why would I not get paid for time, effort, and inconvenience in this? And I said to the, informed consent interviewers at Harvard, I said, that must be a really uncomfortable part of the conversation to get you, because you would then have to say, well, we don't think that you would quite understand the risks and that you would be making a bad decision. And then that person would say, but we're spending an hour right here in this room talking about all the risks, talking about everything. Like, why would I be disqualified from compensation if normally, if this were a different research project, you would be telling me how much I would be getting for all the time and the pain I have to undergo, whether it's taking a biopsy of my lung or whatever it is. And so I told the committee at the National Academies, it's not a choice between compensation or no compensation and getting eggs. It's either compensation or no eggs. Okay. The choice is in between. Do we compensate or not compensate? Because you're not going to get any volunteers in the non-compensation route. It's you have fair compensation and move the research forward, or not be able to get any volunteers. There was actually one volunteer at Harvard that did make it through the process, but then they determined that she was psychologically and mentally incompetent. So if you want to find out who is psychologically or mentally incompetent as an egg donor in the Boston area, it would be the person who says yes to that for no pay. So yeah, I mean, it's been really interesting, that I think the current safeguards we have, the concerns are, you going to entice women to donate eggs because they're poor. Okay, well, the IRB is not going to let you sort of target poor communities with your ads and recruit just from poor people. People will say, it's going to blind people to the risk of egg donation. Well, I think that taking money off the table is an unproven way to improve comprehension about risk. There are better ways to improve comprehension about risk. Teach back method, there are different methods you can use. They're talking to the person to really assess whether or not they're understanding what they're getting themselves into. There are other more proven ways to improve understanding than this unproven way of taking money off the table entirely. That's a very indirect way, I think, of enhancing and empowering people to make good choices. I think the real question, this is how I ended the commentary in Nature, the real question is not whether to compensate or not, but how much. At what point does it become an undue inducement? And that's a harder thing to set, but I think the question of payment or not should be settled in the favor of payment. Right. So so I do agree that there are concerns. It's just that the burden of proof lies on people who say that there's no safe way to go forward.
What year was that commentary published?
I think it was 2006 or 7. Yeah. It's called Fair Payment or Undue Inducement, I believe is the title of it.
So about 20 years later. And, here we are now. And one of the things we spoke on in our last call was, okay, there's what you just described insofar as the donors of biologics. Now we're moving into this space of, donors of their digital data, their digital twin. And what that means for research paid by institutions, but I think also more broadly when it comes to just the use of these publicly accessible LLMs, whether it's Chat GPT or Gemini or whatever. A lot of your information, your thoughts are essentially shared. But let's say within the realm of biology, there's your electronic health records, but even beyond that, your wellness records, your real-time state of your health. Then there's your longitudinal data, the way that you have interacted with the world over time, like your story, how that rich picture can actually, greatly inform, say, the future of, we call it the age of scientific wellness as defined by Dr. Lee Hood, right? Where you're considering your data in the context of you and different versions of yourself longitudinally, but also people, let's say most like you, or, who should be considered in context. In fact, we talked about this last time. Stephen Jay Gould wrote this paper. The median is not the message, right? Where he was diagnosed with the stomach cancer, and his prognosis was, I think, 8 months was the median, right? So he did the research and learned, well, actually, it got a whole heck of a lot longer than that. I think it might have been 10 plus years, because he learned that he was on the long tail, like he was healthy, socioeconomic status, caught it early. And so the outcome was steered by, let's say, his access to information. In the process of informatics in itself, going from the data all the way, from the data to the information, which is applied, and then the contextualization of it, and let's call it the knowledge that becomes wisdom, and wisdom being defined here is by acting on that new knowledge, right? So we have these, as individuals, we have these knowledge islands that are measured in relationship to our, let's say, previous self, maybe the desired future that we imagine for ourselves, and, further contextualized by people who are probably most like that end state that we want to achieve, or that next state that we want to achieve, and are also starting from a similar starting point. That's going to be the most precise path, I think. And the anecdote where I see this to be most true is not the right way of saying it, but where I find the most motivated subjects are, athletes pursuing goals, right? Athletes trying to break world records. That's on the human performance side. And then, at the other extreme, it's, people with, let's say, rare disease or critical, health issue that they're trying to navigate, like the instance of Stephen Jay Gould. So the point is there's an extreme situation that pulls an individual, toward a specific aim. Not to say that if we don't have that extreme stressor, we're not pursuing some kind of goal, but there's that kind of middle of the bell curve, maybe, where we're not so intentional all the time, let's say. But the point is, you can, I think, see the implicit value of an individual's digital twin. And I think that's just going to get more and more explicit over the years, right? Like, we're going to be able to map back to, well, we had this cluster of individuals, let's say, who had a rare disease that, or a complex disease. So now, because we've been better able to, let's say, partition, quantify, and define the root cause of these complex disorders, these individuals are going to have a role to play in developing the cures to the future. And so, and I see a parallel there with, like, the HeLa cells, the stem cells, right? Like how, those are just not properly procured, and, all of these great therapeutics were developed as a result of the donor cells. And so that's, I thought, one area that I thought we might go, but I think the important thing is to come back to the philosophical frame or lens that we're starting to implement, because one of the things that really got me excited for this call is, like, well, how do we make philosophy cool again? Because philosophy is like, oh my gosh, this is going to be a long conversation, and I don't have the mental real estate for this. And it's like, okay, well, not to diminish it to, like, philosophy for dummies, but, like, how can we make philosophy exciting? Because I'll say one more thing for context is, one of the things that I've really begun to appreciate with these different tools is, there's for me, previously, a huge administrative burden, things that would really take a lot of my time away, sending emails or analyzing complex spreadsheets. And you can automate a lot of that stuff. Like, I think about my PhD, and I'm like, oh, I probably could have done all that work in 4 months instead of 4 years, which of course isn't true, because part of the journey was the stumbling and the learning. But you can see there were certain things that took a lot of time that, can be done a lot more quickly. And if we're kind of sharing these methodologies as a learning methodology, is it an opportunity for us to go back to and emphasize the humanities, similar to, I think you had that intuitively, where you're going along, I'm going to do med school, and you're like, wait a minute, what's the question? Why are we doing this? And there's that kind of pause before we kind of invest all of this energy perhaps going in the wrong direction. So yeah, how does this apply to the digital age, digital twins, and are there learnings from the past that we can pull in, and how is this more accessible to obviously the current generation, but the next generation, right? Like that's my concern. How's this going to be easy for my daughter who's 2 right now to understand, and yeah.
No, these are really great themes that you're raising around AI, and digital twins. So people are really, really quite, I think, concerned and confused about even what to think about this. Like, is this a good thing to do? Is this a bad thing? So let me kind of give you a little bit of background about philosophy, because I think a lot of people, usually kind of people I meet day to day, like they don't really understand what philosophy is, academic philosophy. So I need to point out one thing just in the very beginning, and that is there's 2 main types of doing academic philosophy, what we call continental philosophy and analytic philosophy. Continental philosophy is kind of what I think most people think about if they think about philosophy, kind of like big questions. They're like, why are we here? The meaning of life. Like basically, they're like super big humanistic questions about meaning. But in the continental tradition, which is taught primarily in Europe, the way I would put it is they raise and they tackle big questions in a very imprecise way. What analytic philosophy does is they kind of take really minor questions, I think, relatively speaking, and approach them in a super rigorous, logical way. I wish we could address the big questions in a very rigorous way. That's kind of my hope for kind of the best type of philosophy. In analytic philosophy, which is taught in the US, the UK, Australia, Canada primarily. So schools like Stanford would teach analytic philosophy, very logic based. There was another program at Stanford called symbolic systems, which now I think kind of laid the foundations for AI because it was very popular with computer science majors. It's basically like logic, programming, computer science. And that was very closely related to the philosophy department. So what I was trained in was symbolic logic, modal logic, basically, turning that approach to philosophical questions where it was almost like doing math with words. You would take an argument and kind of break it down to kind of like logical rules and implication and this and that, and you would then find like which step in your argument is kind of the weakest logically, and you have to bolster that and restructure your argument back into like English paragraphs and sentences. So it's very much a good kind of humanities area for people who think like engineers. Okay, so analytic philosophy is what I was raised in. And what was very dissatisfying about analytic philosophy is that like we were interesting questions which were super interesting to philosophers, but like no one else. We're super niche. It was almost like arguing who's stronger, Superman or the Hulk. So, but who cares, But like you have like super really rigorous arguments about like when you make an ethical judgment, is there an internal motivating factor for the speaker who utters that sentence? It's almost like getting into like linguistics and even like a little bit of psychology. So it wasn't like the big questions that people really in the public were wondering about, like what should I do with my life? What makes a good life a good life? Bioethics kind of then bridged a little bit of that because it would ask questions like, what does it mean to have a good death? If you're a patient and you're suffering horribly and there's no cure, what does a good death look like? How would you define that? And then you would have to argue with logical arguments against a whole slew of other perspectives that are coming in and saying, if you believe in human autonomy, if you believe in the right to make your own decisions, and every decision in the end of life is one after the other, people are making about what to put you on, what medications to have to kind of alter the time of death. Why can't the person whose body it is ultimately be the decider of what their last days are going to look like when we empower patients to do decision making all along up until that point? So it's that was a good example of, I think, big questions in the clinic, life and death, what does it mean to be conscious in the ICU? Big questions that you had to tackle with quite a bit of precision because you were up against lawyers, you were up against physicians who are very used to thinking very systematically. So you have to present your arguments in a very logical way. So I'm kind of realizing now that's probably why I got really just interested in bioethics. it combined the big questions with the methodology that you would need to have a strong, strong position you can defend against anybody who would attack it. So that's a little bit of the background. So we're not talking about continental philosophy. We're not talking about Sartre, Kierkegaard, and these people who are kind of Dostoevsky, the existentialists. We're not talking about that. Although those are, I think, the most important questions about what does it mean to be a human, right? So when we now turn our gaze to AI, to digital twins, I think that kind of combination of the big questions, but kind of attacking them with precision, with logical arguments that pretty much anybody, regardless of your culture, can kind of like follow, because logic we think is universal. I think that would be the approach that I would most like people to really take seriously.
So that's a good contextual frame. So let me ask you a question. If I was to, because you've got people speaking on this notion of, say, transhumanism or the singularity, right? And there's talk of uploading a consciousness. Well, what is that? And even if it isn't fully defined, but there is, let's say, a digital twin is put together of my thoughts, and people are creating these for themselves now. Like for example, creators will, hosts of podcasts, for example, will record themselves or, upload videos and speech patterns and, essentially create a digital twin insofar as their ability to be a host. And in that way, I suppose that's a consenting individual is doing that, and they're doing that for their own aims. And again, it's a kind of a thought partner, cloning yourself, so to speak. But take a look at everybody, probably most people are familiar with like Superman, right? And Superman arrives on planet Earth, and his father's consciousness is, I'm not sure if his father's consciousness, the record of his father's way of thinking that is, again, depending on which version of the movie you've seen, it's interfacing with Superman. It's for all intents and purposes in Superman's mind, that is his dad, right? Because his only working memory of it. And so would Superman's dad, would he feel that his intention was met, right? And could it be manipulated to serve something else after his physical form is gone, right? And I don't know that we're thinking deeply about these things, but as let's just say, my own father, as he's nearing the end of his life, would he want that? And for his children, would his children like that? Would they think that was weird, right? And then again, you can imagine a more, let's say, commercial instance of this. I think actually back to, you probably remember the movie Her. I think it was with Joaquin Phoenix and Scarlett Johansson, and she is the AI girlfriend, and she eventually meets up with a bunch of other AIs, and one of them was a consciousness of Alan Watts, right? And I think there's like the Alan Watts Foundation where they have all of his speeches and records available. But I mean, if you can just go to YouTube and you can see thought leaders, their speech pattern, they're putting into they're being put into a form and perpetuated. And it's funny because when you listen, there are subtle differences where you're like, oh well, this is clearly like an AI, because the intimacy is lost. Like you can see clearly there isn't an engagement with a specific audience, right? Like I even think about, like, say, live performances of singers when they go off tune by accident. It makes it for let's say, a rich experience because there's something unexpected about it. But you can imagine a future very soon where you can program that and you can anticipate what the viewer would perceive as a surprise to make this feel more intimate. And so I think you can see very quickly it can become confusing insofar as what reality is. If the AI is matched so well to your preferences. So there's a couple of things that I'm dancing around there. Like one is just, okay, the ethical proliferation of somebody's ideas in the form of something that actually resembles how they sound in speech. But you can see how this could be very quickly, upgraded to, how they look, like as per the podcaster example. And I don't know. And then tease that with biologics, go into the movie Avatar, for example. It's like, okay, well, now maybe this gets uploaded into not an android robot, but like an actually grown human. So we're way out on the edge here insofar as like science fiction, but I think that's what kind of maybe you can help me find a coordinate in there, which is a helpful jumping off point without, sensationalizing, because there's a lot of good that AI is doing, but how do we proceed pursuing the intended consequences, or sorry, intended benefits, but being aware of what the unintended consequences might be?
Yeah, it's so fascinating to me, like all these recent developments in technology, because back when I was a student in philosophy, we would do what were called thought experiments, kind of tease out what's essential to things like, what makes the same person over time. And we do like these thought experiments where you would change one little variable in the scenario and say, does that really matter? A lot of them kind of like borrow from science fiction, like teleportation and duplication of people.
Mm.
And then you get like these technologies that could actually biologically twin you, right? So biologically, I mean, what's happening with cloning, although you have different mitochondria because it comes from a different egg donor, you have a genetic twin that's later born. Like that's what the analysis was in the Dan Brock paper that I worked with on with ethics of human cloning. What we determined, the conclusion of that is once you sort of disabuse people of like all sorts of misconceptions of what cloning would actually achieve, it won't Xerox people and their personalities because that's also largely determined by environment and culture. Well, she disabuse people of that, like the interest that people may have on cloning other human beings for reproduction and the concerns people have kind of drop away if you get rid of that genetic determinism, like your genes define everything about you and all your experiences. And so the conclusion of the paper was, well, actually, there's not much to be said for like why anyone would want to do this because it would just be a later born twin, it would be genetically identical to you, but separated in time. Right. So the reason why I bring that up is now we have these new technologies that kind of, you don't need thought experiments like in the hypothetical science fiction scenarios anymore. We can apply these like same analyses to real technologies that actually make it conceivable or possible that you can do the following. Here's the interesting possibility to ponder. So you develop the AI twin technology, right? And you kind of have this whole other like way of sort of maybe keeping the person's values, memories, experiences kind of extended temporaneously past the person's lifetime. So you have some like kind of way of like digitizing all that and keeping that sort of like narrative going. You can also at the same time now, we believe, take cells from that individual, a cell sample, tissue sample, reprogram those cells into pluripotent stem cells using iPS cell technology. Then you cluster them together to form an embryo model, which you can make as many of these as you want because you can generate millions, billions of these stem cells from the person's tissue sample in a mortal cell line. And you can take as many shots at the goal as possible of trying to recapitulate that person's embryo formation and maybe even carry that to term. So you have endless possibility of having, not, you mentioned avatar, like, but it will be your own biological twin as an infant that would grow, and then you can upload the memories. And so like the whole thing about cloning back in the day during the Clinton years was, once a person dies and you clone them, it would not be the same individual because there would be memory discontinuity. You'd be raised in a different environment. But now you have the biological substrate you can reproduce. You could sort of recombine or reform the early embryo development of that individual using their iPS cells. And if there's a way to then upload the digital twin, kind of like the consciousness or memory into that being, then you would have an identical twin that actually would carry on the memory. So you can kind of like you can have a biological home for that. You wouldn't like live forever in a computer. You would maybe be plopped back in to your physical twin. So that's wild, right? So because one without the other is not as cool as kind of like having the idea of like you would be reborn basically, and you would continue your consciousness would continue in that. So that's not a radical thought experiment. It's kind of within the realm of what I think could be possible in the next 50 years or so or less, if we really wanted to go that route.
Have you seen The Matrix?
Yes.
Right. So there's that, pivotal moment in the first one where Morpheus is explaining this future where human beings are no longer born but grown. And I think that's actually the Superman paradigm too, again, depending on which version you're looking at, is humans aren't born, they're grown. In Because where my head went initially was, well, probably the debate around, pro-life versus women's rights, right? And so when does a fetus become a human, let's say, when, like, and so I wonder if we could tease that apart here. Obviously we're not going to solve it, but is there, can we learn from those debates if this future that you're describing, is possible in the next, 50 years? Like, does that become an issue? It's like, well, okay, you might say, well, the mother isn't bringing the child to term, so maybe none of this even applies. But then you're like, well, but if you were to grow a human,
Yeah.
and because we've never done that, right? Like, grow it
Yeah.
in an artificial womb,
Yeah.
for example, would it have a consciousness on its own if you didn't then upload the memory and basically transform that?
It should have its own independent consciousness and personality, just like any identical twin would. Right. But okay, so let me just preface all this by saying I don't think any of this is imminent, but we're just kind of talking about, well, what would be conceivable,
Yes.
manageable, possible, given where technologies are going. What's fascinating to me is, and this came up in the cloning debate, it's so funny how things kind of go full circle. So let's all the way back to 97, right? So the resulting clone, you're not actually the parent of it in the kind of biological sense. It will be your sibling, right? It'll be your identical twin. And so the question becomes for me, like, is there a right, like, could someone claim a right to say, based on my own autonomy, personal autonomy, I consent to donating my tissue sample to be used in this way? So then the only other thing that starts to come into play is, will you need a surrogate? Because we'll have to get that person's consent to carry the embryo model, stem cell-based embryo model to term. Again, assuming that we're in a world or in regulation, policy, like this is all possible. I think that's that's probably not gonna happen. But so in that world, you don't need the consent of a reproductive partner. You're just reprogramming your own body cells to then create this embryo. And by the way, what I'm talking about here is very achievable in current technology of embryo modeling. I mean, they're not developmentally competent yet, but they're getting very, very realistic. These embryo models made from stem cells that go through all the stages of embryogenesis. Okay, so as long as you get permission to do this and you know that it's happening, like what kind of, it's not really, it doesn't sit comfortably under reproductive rights the way we normally think about it, but I think it is in that category of reproductive rights and decision making and autonomy. So if you can't find a surrogate to safely carry this thing, then you would have to rely on some kind of ex vivo technology, right? So like outside the body gestation technology. Now that's also kind of something that we're talking about at the scientific level, because there are people who are trying to culture either real human embryos or embryo models made from stem cells pretty far along the development outside the body, from the moment of fertilization or initial creation to, let's say, 14 days or a few weeks, post fertilization. At the same time, there are other people who are working on these technologies to give extreme preemie support in NICUs, so kind of creating artificial womb environments for what would otherwise be non-viable fetuses that are just delivered way prematurely. Eventually, I think those two technologies and timelines can meet. And if they do, then you can have something that goes from all the way from the very beginning to delivery outside the body. So anyway, so these kind of technologies are swirling around. What's really fascinating about the Dolly debate back in the day was that was one group in Scotland working in animal science, working with sheep, right around the same time that human embryonic stem cells were derived from IVF clinic embryos. Now, they didn't plan for the two to come together, but someone said, this development in one part of the world, another development in Wisconsin, can you imagine putting the two together? Like, that was not planned. People said, oh, well, now, what if we created our own embryo using cloning technology? Then the stem cells we got from that would be genetically matched to the cell donor. There would be no fear of rejection if you derived any kind of tissues from that. And you can study all kinds of developmental diseases if you take donors who have complex genetic disorders that you want to study at the stem cell level. So again, no one's planning so to speak, to have external gestation. But you have these two different groups working, two different trajectories, and it's always kind of the combination of two unexpected things that I think leads to really, really big controversies because nobody could have planned for that. It's just kind of the right timing of things coming together. So again, I'm prefacing all this by saying I'm not saying that this is going to happen, that the policies and laws are going to be set up to enable this. But where you kind of see different trajectories of research happening, I can imagine that it's conceivable that they can start colliding together in these really interesting ways. Embryo modeling, right? External gestation technologies. And then there's this whole idea of the AI component or kind of like the consciousness component. Imagine a world where they're all developing independently. Imagine a world where someone gets a bright idea of combining them.
Oh, and just maybe one more far out there question: is it then? So say we come to a point where we can get a comprehensive picture data set, if you will, of my consciousness, and that can be on that's information that will be in transmission to the next generation. Let's say, is that me, or is that like the teleportation idea or a time traveler idea? Is like that's not you anymore, but you are showing up new, but you're reborn.
Yeah.
But you actually died.
Probably so here's what's also fascinating is cloning kind of raises this possibility. And then this scenario raises too. You can have multiple copies at T0. You can do like no one says you have to just have one version, right? You can do like 100 embryo models, 100 of them gestate, and then 100 of them get plopped in this AI program, right? So at T0, I would say you're all identical. But immediately after that, you're assuming that they're going to then have their own experiences. They're going to start diverging after that, branching off. So there will be some initial point where you'll say kind of like totally kind of counterintuitively, because normally identity is a one thing, like 1 = 1. It can only be one thing for something to be identical to itself. I mean, I guess you could have identical copies initially of one thing, right? But normally when we talk about human identity, personal identity, it's difficult to imagine for very long there'd be multiple copies of an individual that would remain identical. I mean, they would branch off very quickly.
Right. The what it makes me think of is, say you were uploading the consciousness. It's like, well, whatever that new entity is, that consciousness kind of came in as part of that package as not an identity, but as a memory, right? And so is that an advantage or is that a burden? And I think that like there is a biological analogy of that we know exists to be true today, and that's your epigenetics, right? Like your certain tuning based on the previous experience, in particular the mother, the environment that she found herself in, like the Dutch hunger famine, for example. That's going to tune the expression of different profiles of genes that are going to manifest in the form of, say, increased incidence or likelihood of paranoid schizophrenia and obesity, because it makes sense to be hypervigilant and to store your nutrients for later in wartime scarcity. So, and I suppose that's useful if you're born into that, but then it's not so useful when you're not. So you can see, like, oh, you might think it's a benefit to, like, oh, how do I take everything that I learned and then give it to the next generation? It's like, well, I don't know what you learned. Is like, it's important, I suppose, as a memory, and it's an enriching story to have. But if it's kind of acted out as the truth, I can imagine a scenario where that's actually quite detrimental if it's not properly integrated into this new entity that we're describing.
Yeah. We've been talking about memory in a way that I think kind of loosely, very loosely, right? Because when you speak of your own memories, you don't remember every single thing. It's very selective. And so either the very selective memory is going to be passed on, or someone's going to have to edit stuff out. I mean, I guess with AI, an AI chatbot, it can remember, so like we call every little detail. They can bring it all back, but that's not real human memory. Human memory is not like I need to remember every single word of our conversation that we're having now, like next week, every single word. But AI could kind of recapitulate that. So I think when we talk about memory and life, we're talking about even twins that are having undergoing the same experiences in the household will have different memories of that. That past will mean different things to them. So I think memory is sort of shaped at the time of recall. It's not like computer memory. So I think that's really interesting, right? So again, just like kind of like the analytic philosophy kind of approach. Like, okay, so remember that term. How are we using it? How are we defining it? And then are we conflating and going back and forth? We think we're talking about the same thing in the digital twin case and in the biological case, but they function differently. And then which of the two senses is more important here for ethics, right? So again, just kind of unpacking some of that, I think is useful, and that's where I think kind of I don't know if it's philosophical training, but people who are kind of like who enjoy philosophy, kind of I think have something to contribute here to the discussion. Kind of like kind of like questioning the way we're framing the question, questioning the way in which we're sort of assuming the background conditions for what we're talking about here.
Well, right. It's like the first step is coming to terms, right? Because I'll even add an additional layer of complexity. Because I'll think about memory, collective memory, as a culture, right?
Mhm.
And in a way that, well, how that is recalled through story, as an example, is like, we come and we gather around the holidays and we tell the same story, and it helps us to remember something, to maybe even activate something that is latent in us psychologically and biologically as a result. So I think it's like, where you've got me thinking is like, well, what are the existing technologies, for example, today, that allow for that, like, information transmission, like intergenerationally? Like for me, that's what's really interesting, and that's what really caught my attention in my towards the end of my undergrad, but tenure into graduate school. But not until this was said to me by my to be graduate supervisor, Ford Doolittle. He said to me, look, you've learned about genetics and DNA as this, thing that expresses, you know, gene expresses a protein and has some kind of function, like enzymatically, and that's going to lead to the health of an organism, because we're talking about biochemistry department, microbiology. A lot of these people were pre-med, and so they're interested in that mechanistically. And so there's some biologists, some evolutionary biologists who are thinking about things in terms of fitness, right? Like, so is that sexual selection? Is there some kind of a, nutrient scavenging or processing advantage? And what Ford would say is something like the most potent, let's call it, measure of a gene's fitness is its ability to pass that information on to the next generation. So it's like, really, like, the best genes are those that pass their information on to the next generation. And that was really, I think, kind of in favor or nod to, the junk DNA, right? So it's like, well, none of those genes are doing anything insofar as we can tell, but their information is being passed on over and over and over again. And, that kind of comes into the reductionist frame, let's say, of, what's his name? Richard Dawkins, right? The selfish gene.
Right. Yeah.
And so I think, like, information transmission is really interesting. And then when I talk to parents, and now that I am a parent, it's what I think of is like, okay, well, how can I help you make less of the mistakes that are not necessary that you make, and particularly the ones that would be fatal. And so I wonder, like, is there a role, for when you talked about memory? I mean, even just today, to help to organize our memory and anticipate the contextual dissemination of call it even a curriculum. Is like, when is the best time for a human to get access to this kind of information? This already exists in the school system, right? So, but can that be personalized? Can that be optimized? And I think that's something like a very, interesting application, today, of, let's say, remembering through, now I'm referring to, I jumped around through molecular, but then I was also speaking of cultural transmission as well, right? So to me, I see it as like kind of the intersection of those things, of the cultural, which is, it's not matter, but it's made to matter when it interfaces with, with life. So I think that's really interesting. But coming back on, the original question, which was, okay, I have all this data, which could be life-saving to somebody else, and now there's a company or a research organization that wants to leverage this after I'm dead and gone. Let's assume I'm not coming back in a grown human state, but my family recognizes that my data, and therefore their data, right? Because a lot of that is going to be based on DNA, is being leveraged to, I think, create a better future for tomorrow and cause less pain is great. I think there's just the issue that we have to speak to in terms of, well, what do the economics of that look like, right? And that kind of brings it full circle of something that is maybe here more of like an analytical philosophy, which is now that individuals' digital twins could be accessible globally, should they be compensated for the good that is facilitated, and how do they share it with informed consent?
Yeah, it's really interesting because for me, the medical content, I mean, maybe just because of some of the world I operate under academically, but like the medical justification and context for digital twin, I think is very strong. And it would be ethically, I think, pretty unproblematic if you had the full awareness and consent of the person that's being twinned for their own good, for their treatment, for prediction of their health. I think that's fine. I don't see too many red flags or if any. Once you kind of get outside the realm of the person's kind of being involved in the decision and how it's being used, if it's being used for their benefit or for some commercial profit making for someone else's goals, that's not so much about the digital twin technology per se, but sort of who gets to own the technology and apply it, and for whose benefit is that being used. And if the more it departs away from the best interest of the patient or the person who's giving consent for this, the more problematic I think it becomes. So I think, just context matters a great deal here. And I also think like the route to technology development, if it's first like a medical rationale for the technology, and then it gets kind of like repurposed or there's kind of secondary use for kind of other applications, then what may initially have been innocuous could kind of turn very problematic in that second tier. Or you can, I think, much less likely. Well, I don't know. That may be where all the money is. It's just kind of directly try to aspire to doing this kind of not health related digital twinning with some other kind of sense of immortality or something else. I think that there could be a lot of like venture capital and computer science interest in that, but that's not really meeting a deep kind of medical human need. It's kind of serving some other end. And then you have to ask, well, okay, so what's that goal? Like, why are you trying to do that? And that's where I think the problem of sort of like trying to find a toehold or a standard to assess ethically what's going on gets complicated if what you're doing in this technology is kind of upheaving some of the basic concepts of like what it means to be a human or what it means to be alive. Like if you're kind of in the process of undermining our traditional understandings of those concepts, then it becomes really tricky to kind of how you're going to evaluate that, because we have to have some kind of set of standards ethically that we agree upon to then answer the question, this is a good thing or a bad thing. Where it gets really tricky is what technologies are kind of redefining some of those basic categories you're using to assess that very thing. Then it becomes very simple because then you don't know, well, then where else do we turn for another standard to then look at this repackaging of the concepts. So I think that's the most problematic kind of scenario for me, whether it's biotechnology, whether it's like lab grown sperm and eggs that redefines what it means to be fertile and infertile. If you're kind of making these embryo models from stem cells and there's no fertilization to happen anywhere, or you're doing cloning, who's the parent? It like disrupts kind of standard categories that we've always relied on. What it means to be alive or dead in the ICU, that was a big thing. Like, is it just the heart beating, or do you have to have higher brain function? Those categories of what we thought were kind of givens are getting disrupted by the technology itself. So in those scenarios, that's where it's like I think the most exciting in philosophy and in bioethics is kind of grapple with that situation. It's a debate that's upheaving the very kind of foundations of kind of what sets up the ethical problem in the first place. It's just a weird scenario where you don't have a strong foothold anywhere to kind of apply thought to what's happening.
This kind of brings me full circle to the people who are listening. So, and I maybe I'll name like Kristin Lee specifically, who, recommended this conversation, because here she is, she's at this moment, probably very similar to where you were when you were deciding between philosophy or medicine. And, given the state of, the way you see the world, um, and what you think is needed, let's say from, certainly we're biased, and we wanted to make philosophy cool. But I mean, I think what we're saying is we're saying now more than ever, it's important to apply, philosophy in way like, so the analytical philosophy that you had mentioned, that I think that remains. But this notion, even of the more continental philosophy, is because the thought of experiments they're more feasible now. Like as we just kind of talked through. So what does the next generation need to know? What advice could you give to them? This is kind of a couple parts here. So like number one is like, so what does someone like Kristin Lee need to know, in the next generation, the young minds who they're sensing these problems, and they're really excited to understand them. How can they understand them? And from a partnership perspective, is like, who are the partners, whether they be institutions, whether they be groups of individuals who are aligned with this kind of abstract thinking that you as a leader are kind of, and thought leader are provoking, let's say, or being progress. So what do we say to something like Kristin, and what are the organizations and partners that can be in collaboration of kind of refining this worldview that we're kind of stumbling through here today?
Yeah, absolutely. I used to tell my students, my college students, now when I was their age, I could not have planned at that time what I'm doing now, because embryonic stem cells didn't exist. All the stuff that I'm dealing with now was just not even like on people's horizon. The idea that you could reprogram a somatic cell into a neuron and then build things with that, and build these constructs in the lab that recapitulate different parts of the human body. We didn't. That was all science fiction. So I couldn't have planned for this career and what I do now. What I think is essential is that you develop a core set of competencies, right? Critical thinking, clear communication and writing. I don't know how important that's going to be going forward, the writing part of it. But there's some core competencies that are going to allow you to enter into these really amazing things that we just can't dream of yet, but that are coming. Like, our imaginations are so limited, we can't even imagine what's going to happen when they're my age. Okay, so what I was able to do was just kind of, it's so interesting. Yeah, I'm so glad that my philosophy dissertation advisor told me, you got to focus on something that's like going to make you useful in interdisciplinary teams, but it's really the interdisciplinary work that's going to move you forward. Like, you got to bring something to the table. So something like philosophy is ethics for me. For other people, it might be, legal knowledge, it might be engineering knowledge, something. But the future is not siloed in these academic departments anymore. That was like out of convenience, but the world is not siloed in that. The world is super interconnected. It's going to be even more so going forward. So get training in something that you're really good at that will allow you to bring that same skill set to different teams. Now, there are some people who are like incredible engineers. They would be great on a team for like medical AI or even like bioengineering. Like, they just have that natural mindset and curiosity. So it's basically, what I'm saying is develop core competencies that kind of translate well, and don't worry too much about if, here's my one clear path to my future, because it's very rarely ever a clear path, single path. Like in my case, I was bouncing around all over the place. But what remained constant was the way in which I think and the way in which I really enjoy engaging with other people and bringing what I can do best to a team. In terms of networks, in terms of environments to facilitate that, you really should be in environments that enable this kind of cross-disciplinary work and collaboration. And in my case, my secret sauce, I think, for bioethics, when I look back, it was, I started off because my dissertation was on individual autonomy, philosophical theories of autonomy. I got interested initially in bioethics with medical decision making. So I did a lot of work early in hospitals and in clinics, and work on end of life issues, medical decision making at the end of life, euthanasia, those kinds of things. When you're doing clinical bioethics, you have to go to the hospital, you have to talk to doctors, you have to meet with patients. You can't just sit in your office or in the library by yourself and make pronouncements of what patients should do or doctors should do. That would be like philosophical and bioethics malpractice. Like you don't know what you're talking about. When I moved to stem cells, when I moved to like bench science, I very naively thought, oh, I need to go to lab meetings. I need to work with scientific teams. I need to learn the science. And I looked around and I realized hardly anybody was doing that. They were still sitting in their offices talking about the moral status of embryos because they could just kind of take theory and just drop it right into that context and not have to learn anything new. So in terms of networking, you got to work with people who come from different disciplines to solve very complex problems. You have to be in an environment that encourages that. And you actually have to enter these other worlds and learn from kind of, the scientists that are doing the work. So that was my secret sauce, is sort of, working very closely with top people in stem cells, the bioengineers, as the whole field continues to evolve in really amazing directions and kind of open up these whole other areas of inquiry and science. I'm still kind of right there working closely with them. And it's that kind of collaboration that makes me, able to publish in some top tier journals and kind of be more at the forefront because I'm constantly interacting with them. So those are the things. You just bring your skill set. I don't know what the collaborations are going to look like over the next, 10, 15 years, but it's going to be something that doesn't exist right now. I can tell you that it's going to be something new. So you can just be open to it.
For sure. And that's where my head went with like, well, these kind of partner organizations that are facilitating this cross-disciplinary, ecosystems and breaking down silos. I mean, it sounds to me that I think what, in your experience, it wasn't like, well, I'm going to go and find cross-disciplinary institutions. Like, no, I'm going to go and create it. But by getting out into the real world and experiencing it. And then just that, I suppose you would be looking for institutions that were, innovative insofar as implementing interdisciplinary process. I mean, these were emerging in my undergraduate days. Like they were the Department of Interdisciplinary.
Mm-hmm.
So, but even those can become quite siloed, I think. And so then I think what you're saying, it's kind of the individual, they have to define their own path. So just to reiterate, I developed some kind of craft of let's say specialized knowledge, but critical to that would be critical thinking, communication, writing, understanding different worldviews. I'm putting language, adding some flavor, like in terms of read broadly, but also go deep. I think there's a version of that you're pointing to. And, on the theme of going deep. I mean, I think we went broad. I think we went deep on some areas, and I can think of thousands of other questions that I know are going to come out of this and that listeners will ask. And so I would, reserve the request to come back to you with, follow-up questions, because I know I'll get them. But before then, I would ask, is there anybody who you would nominate for my next guest on the DNA of Things?
Absolutely. So there's a biologist named Michael Levin at Tufts University. He is, I think, a leader in synthetic biology and just all sorts of really cool experiments. He did one of these first experiments where they created a biological robot using frog cells. And he's, I think, the scientist that I think thinks most philosophically about the work he's doing. If he weren't a biologist, a synthetic biologist, I think he would have been a really great analytic philosopher. He has this interesting view of consciousness, that he's kind of on a spectrum, and consciousness is always kind of defined for him as kind of the ability to solve problems. So he thinks individual cells could have that property, basic property of consciousness itself. It's a controversial view, okay? So I will say that, but it's extremely interesting, and he can articulate what he means by that in just an amazingly accessible way. So I would highly recommend Michael Levin, Tufts University.
Amazing. Michael Levin. I will reach out and mention to him that we had this conversation. Dr. Insoo Hyun, thank you so much for going wide and deep with me today. It's been an absolute pleasure.
Well, it's fun getting into the DNA things with you, Jeremy. It's been a blast.
Once you see the hidden machinery behind scientific decision making, you can't unsee it. What Dr. Insoo Hyun reveals isn't cynicism, it's responsibility. Ethics, in his telling, isn't a brake on innovation, it's the compass that keeps us from mistaking speed for progress. When technology reshapes the very categories we rely on, life, consent, personhood, the most dangerous move is pretending the answers are simple. This conversation leaves us with a quiet but urgent challenge. What truths are we accepting because they're convenient, not because they're sound? And where in our own lives, our work, our health decisions, our use of technology, are we outsourcing moral judgment instead of engaging it? The future Dr. Hyun describes is already here. The question isn't whether these technologies will shape us, but whether we'll have the courage to shape them wisely. Thank you very much for joining me on this week's episode of The DNA of Things. We'll catch you next time.